Welcome to solverfy.
Hello, my name is Margaret, and today I'm going to help you with with a question from chemistry, the molecular nature of matter and change. Uh, and, and this is chapter 2016 of the 7th edition. I'm going to be working on a problem from chapter 8, problem 6. And the question states, which of the quantum numbers relate to the electron only, and then which relates to the orbital. Now, not the biggest fan of this question because hypothetically, they all do both. And the reason for that is because an orbital is a probability of where an electron is around an atom, because the whole point of Schrodinger's equation and orbitals and all those radial probability distribution charts is that we can't exactly know where an electron is, and we can't exactly solve any of those equations, and so we had to use probability functions instead. And so we decided, okay, well, we'll just come up with probabilities and we'll give it our best guess. And so orbitals are essentially these maps of where an electron is most likely to be surrounding the nucleus. But we do know exact spins of electrons, and so the spin number tells us exactly what spin an electron is, even if we don't know exactly where it is in that particular area. But I can say that we do know which of the quantum numbers is, sorry, that's my computer telling me to drink water. We do know which of the quantum numbers is talking about the orbital or about the probability distribution, and which is talking about the electron specifically. The other thing to keep in mind is that sometimes we have to separate out things because it takes several different equations to describe an electron, because an electron is one of those particles that has both wave and particle-like properties. And so it takes several different equations in order to describe it. And that's one of the reasons why it has several different quantum numbers as well, is because some of these describe the wave-like properties and some of them describe the particle-like properties. So if we really quickly recap, we're not going to talk about any of the actual integers themselves. We're just going to talk about what they're describing. So if we go back, the principal quantum number describes the relative size of the orbital. The angular momentum. Quantum number is talking about the shape of the orbital. The magnetic quantum number is talking about the 3D orientation in space around the nucleus. And just to make sure everybody knows what that's talking about, because I think sometimes that's a little hard to interpret. If we're saying that the nucleus is situated in 3D space at the center of an X, Y, Z axis plane, it's talking about where in this plane is the orbital situated. Is it sitting exactly in the XZ plane? Is it situated, over here in exact line with the positive XY axis? Is it way down here exactly with the negative Z? And so that's what this number is describing. And then lastly, the spin is the electronic for the electron. And so if we had to go around and be specific, then we can say that, you know, this one specifically is talking about the orbital, the principal. And then the angular momentum is also talking about the orbital. The magnetic quantum number is also talking about the orbital. 3D orientation of orbital. Sorry, I forgot to write this. So orbital. And then this one is talking about the electron.